intro to functions, and I call it an intro because we're going to be dealing with functions quite a bit this year. So we're going to keep building on this concept of functions. So today I mainly just want you to understand what functions mean and what they are, and also how we can graph them. We'll look at other ways to graph these as the year goes on as well, but today will just be a basic intro. So I just want you to understand what functions are. So the definition is what's highlighted here. It's functions are a rule that generate ordered pairs. And if you remember from the previous video lesson and what we talked about in class, ordered pairs are those XY coordinates that we can graph on that coordinate system or coordinate grid. So really a function just allows you to come up with infinite amounts of points. And in order to do this, you need an input and an output. And you can see right here that X is going to be our input and Y is going to be our output. So basically, you've seen equations like this bunches of times, or a bunch of times, where there's a rule that you follow. That would be the 10x plus 5 portion. You input some number in for x, and you get an answer for y. And what ends up happening is you come up with these coordinates that you can graph, and there are an infinite amount of points that you can plug in, or infinite amount of x's you can plug in to get an infinite amount of y's. And we would still get the same graph, as you'll see, but we could all come up with different points or different inputs and outputs that go with those. So visually, here's what's happening. If you have a function, you have some sort of input, you have a rule. So our input is x. Our rule in this case would be 10x plus 5. And our output is going to be whatever y is. So let's just do a real quick example. Let's say our input is x equals 2. So when x equals 2, that means I'm going to be putting in 2 for x. I would do 10 times 2, I would get 20, and then 20 plus 5 gives me 25. So when x is 2, y is 25, that would give us the points. Remember, these are set up as xy coordinates. So 2, 25, meaning I would go over 2 spots and then up 25 if I wanted to graph that point. And we could literally put in any number for x that we want to and graph this thing. So that's what I want to show you next. This is really the only other thing I have for you today. Let's say we have the function y equals 3x plus 5. In order to graph this thing, we need some points. I won't say normally, but starting tomorrow, I'll give you points to graph. But in the future, you're going to have to come up with your own points. So there are just a few that I like to check out for sure. I always like to check 0 for x, and this is where you can come up with a chart here. So if I put 0 in for x, what do I get for y? So 3 times 0 is 0, and then 0 plus 5 is 5. Now this is a point that I can graph on my grid. So over 0 up 5. 1, 2, 3, 4, 5. That's the point, 0, 5. Alright. I always like to kind of keep them in order integer-wise. So another one that I'm going to check is 1 and just see what happens. I like to keep these as simple as possible. Sometimes you'll have to put in different numbers for x, and you'll see why when we get to that point. But for now, we can choose some very simple numbers. So 3 times 1 is 3 plus 5 is 8. So over 1 up 8. That point is going to be right there. So that's going to continue climbing in that direction. So if I wasn't sure what to graph next, I maybe wouldn't want to choose 2 because that's going to give me a higher number. So I also like to check a negative just to see what's going on if I put a negative in for x. And you'll get used to that as well. So if I put -1 in, I get 3 times -1, which is -3. And then -3 plus 5 is 2. So the point -1, 2. Which is back 1 up 2. And now you can see that we have this line that goes goes through all of these points. And now this line, even though we only graphed 3 points, represents every single point that could be on this function. So the arrows are telling me that it's going to continue upward and downward forever, and it's also going to go left and right forever. We could all choose different inputs, but we would get the same shaped graph as long as we graphed our points correctly. So there are an infinite amount of points on this thing. Even if I were to put in 1/2 for x, there would be, I would go over 1/2 depending on what I got for x or y when I did this. I would do 3 times 1/2, which would be 1.5, and then 1.5 plus 5 is 6.5 or 6.5. So over 1/2 up 6.5. So 1, 2, 3, 4, 5, 6. And there you go. That point is pretty close to being on that line. Obviously, I have a little bit of error with what I draw. I can't draw a straight line freehand. So, but you can. I'm just showing you that there are more points on this thing than we actually graph. So there's more than 3 points. There are an infinite amount of points. Anyway, that is how you graph functions. At this point, we will discover some other ways in the future on how to graph these. But this is just something you can always do. If you're not sure how to graph something, you can always put in some inputs and figure out the outputs and then graph. All right, so there's your intro